In this video, we're going to look at a little bit more of graphing and writing equations of circles. In the previous video, we looked at the standard form of the function for a circle. In this video, as I said, we're going to continue with that. So if you haven't seen the previous video, please watch that so you have an idea what we're doing. All right, we are going to look at finding a function with a given point. Given the point 3, 8 on a circle with center at the origin, find the function for the given circle. For all of the circles that we're looking at right now, the center is the origin, 0, 0. And we don't look at a different one yet. So 3, 8 is on our circle. All right, what we're going to do is we need to remember that the standard function is x squared plus y squared is equal to r squared, where r squared stood for the radius squared. And we're using the numbers 3 and 8 as x and y values. And to find the function that goes for this exact circle, we plug in 3 and 8 in the instead of the variables x and y. And we get 3 squared plus 8 squared, which is 9 plus 64, which is 73. R squared is 73. Now we're going to look at is first r value, the radius, which is the square root of 73. In all of these cases, when we take the square root, you need to think about if it could be a simple radical form in any case. In this case, the square root of 73 is just the square root of 73, so we'll leave it because there's no simpler radical form for this. All right. Then the function x squared plus y squared is equal to 73 fits this function, fits these points. It goes through 3, 8, and it has a radius of the square root of 73. And that's it. That's what we're doing to find a function with a given point. All right, next problem. Find the tangent line to a circle. All right, what's the equation of the line tangent to the circle? X squared plus y squared is equal to 41 at negative 4, 5. All right, to start this this kind of problem, I always think it's good to remember what tangent actually means. So if you Google it, this is what you get. And the first one is actually the most important: a straight line or plane, in this case a line, that touches a curve or curved surface at a point, but if it extended, does not cross it at that point. All right, so we're looking at a line that goes that doesn't go through our circle, but it touches our circle in the given point. That's what we're looking at. All right, so this is our circle. All right, I've created our circle, and you get negative 4, 5, which is the coordinate that we're actually looking at, and that's where a line's going to touch. All right, it's going to touch it in that point. So this is what the line will look like. The line is touching the circle in that point, and it doesn't go through. That's really important for a tangent line. All right, how to find a tangent line is what we need to think about. In these cases, a tangent line to a circle is perpendicular to the radius. All right, so we have our line, and think about where the radius is. The radius, of course, is from that point negative 4, 5 to the origin, right? Because it's from the center of the circle to the circle itself. All right, you see it like this. So our tangent line will be perpendicular to the radius, and the radius here is orange. All right, you see it perpendicular. All right. First, we need to find the slope of the radius, and the slope is always found by rise over run, or as I like to call it, delta y over delta x, the difference in y over the difference in x. All right, in this case, you see that it starts from negative 4, 5, and it goes to 0, 0. That is the slope for the radius. That's what we're looking at first. For delta y over delta x, or rise over run, we do our second point, which is the origin because it's further to the right, and then minus the coordinates of our starting point, which in this case is negative 4, 5. All All right, for the y values, it's 0 minus 5, which will be a negative 5. And for the x values, it's 0 minus a negative 4. And we know that minus a negative actually turns into a positive. So we get negative 5 over 4, or what we say, negative 5 over 4. So that's the slope for our radius. And for our radius, we don't have to look any further because we were looking at a line that's perpendicular to this. All right, now try and remember how we find a perpendicular line to a line that we know. All right, what do? We find a negative reciprocal for that line. All right, for that slope. So we need to find the negative reciprocal for negative 5 over 4, for a slope of negative 5 over 4. All right, so what would it be for this tangent line? 4 over 5. All right, the negative reciprocal is where the fraction flips and the negative turns into a positive in this case. Okay. So we now have the slope of our tangent line. The tangent line that we're looking at has a slope of 4 over 5. All right, let's put it into a function. And a function now looks like this. But we have still one thing that we need to figure out, b, which actually is a y-intercept. To find that, we plug in the numbers from our known point. And the known point is negative 4 over 5, because we know that our tangent line has to go through that point. It doesn't go through our circle, but it is in that point. It's present in that exact point. All right, so we plug in negative 4 as x and y as 5, because that is what the coordinate gives us. Plug that in, and you get this. If we then multiply the negative 4 with our fraction. Remember, if we multiply a fraction with an integer, we actually only multiply the numerator with that integer. So we get negative 16 over 5. And then plus b. And to find our b, we can take it over to the other side, and we find that our b is 41 over 5. All right. Put it back into our function. 4 over 5, x plus 41 over 5 is the function of our tangent line. And there you have it, the function of our tangent line and how we find it. And this is for a tangent line to a circle, because that has a little bit of a different way than doing it for a parabola. All right. Thank you for watching this video. This is all for this one. And I'll see you guys in class.